So I'm basically using this as like a way to funnel people to the school that I created. It's called Epic Projects, where a bunch of cool people just get together and show each other the projects, what they're doing, to help each other out, make cool things, and help people make cool things. And basically, I just kind of wanted to talk about one of the pet peeves that I had, which is people call it reality. Is it a simulation? Is it a what is it? So here's my take on this whole thing. And hopefully this is something useful that you can use. And I believe especially for people who are in science and engineering, they'll definitely be able to find this useful, especially when dealing with abstract ideas. So here we go. Reality is a computer, but a reality is a simulation. So the reason why I don't like using that word simulation is because it doesn't convey the sophistication that goes into as you experience how you experience the world, essentially. Because with the VR stuff, maybe there's a couple thousand like nanites that are making the picture quality incredible or something, or like like the GPUs going through a couple million, maybe billions of processes to get this game to look realistic, to get the physics right and all this other stuff. But when it comes to reality, actually I'll use one of my favorite examples is like one of the most advanced machines that we have is like a 127 step process of what are they called, like to create, literally to make sand into computers. So turning sand to a transistor, those transistors get packed into like freaking trillions or something like that, probably billions or millions, onto a little chip, and then that chip goes to make like your CPU, GPU, and all this other stuff. So that machine that can do that is like, it takes 125 or 127 steps. And that includes verification steps, and then verification steps after, and calibration steps before a step. So it's almost like every one step has like two additional steps or something like that. Insanely advanced machine with 127 steps. Like it literally, like I'll post the link in the video. You guys have to watch it, at least the first like 6 or 11 minutes, because it's a pretty long video. Literally, like when I was watching, I was like, I believe in Jesus, which like I already do believe in Jesus, but like it literally was like, oh my God, like if you don't think God is real after, like I don't know what's it's gonna take for you. Not that I'm trying to like push this on anybody or anything. You'll come to your own conclusions. If you have any questions, feel free to ask. I have some interesting answers, but it was just so unreal that it literally like blew my mind away. So that's the 127 step process of taking the transistors from sand into a transistor, into like microchips for computers. But in real life, just looking at like there's up quarks and down quarks, and they created protons and neutrons. And then there's the electron. So probably like up, down, and then electron. So that's three materials. When they're grouped in a certain way, that three materials creates technically 2, 3. Still, they kind of just create three materials. But those three materials, when they combine in a certain way, create 118 different elements. And then from those 118 different elements, they create everything that you have seen, touched, felt, tasted, experienced. Like your entire existence, from all the trees in the universe to all the freaking galaxies and planets. Like that's the level of just like, with just 118, that's what it created. Hold up, I kind of lost my train of thought. 1 second. Okay, so when people say like, oh, like the world is a simulation and all this other stuff, and it's like, yeah, no crap. Because if you pick up like an apple and you drop the apple, it drops. something has to do that calculation. Okay. I think when we go into the level of sophistication is kind of what I have an issue with, which is why I don't use the level like simulation and stuff like that, because it's like a few things created like literally is what everything else is made out of, and like a bunch of other stuff, like there's gravitational waves and like muons and photons and like all these different things that are just like what the crap, where it's like it took 127 steps to turn sand into something else, and it's like with 118 elements it created like everything that you see. It's like the level of complexity is just unparalleled when we're talking about a simulation that people created versus simulation that the world is. But it does simulate something, right? Because when you drop an apple in real life, something is doing that calculation. Space itself has to change itself to accommodate how the apple is dropping. Like if you drop the apple on the moon, it's different if you drop the apple on the earth, because it's using different parameters. So obviously, yes, it is simulating something. Now people go like, oh, is it base reality and all this other stuff? It doesn't really matter for you, for what we're going to be doing here. Now, on one scope, nah, not really, because it's like you never really. Well, we could, because like technically you never really left Spirited and all of the other stuff. But if you just look at the fundamental thing about making and creating things here on the Earth, how can we use this understanding of the world as a simulation to your benefit? And one of the ways that I do it is that if it exists, it can be figured out. Meaning, if the nature has already done it, that means you can do it too. And ideally, you do it in a way where it benefits yourself, the other person, and the world, and the creatures around you. So this where there's no weird, disharmonious bullcrap that gets made, that dysregulates systems and processes that are keeping you alive. I want you to understand. Because it's like, what happens if you turn off the intermolecular forces? And it's like, well, you know, freaking everything dissipates. Like, I don't know. Like, it's probably, it's an important aspect. Or if you just suddenly turn off gravity, like it, unless it's like, spaceship or something, that's probably pretty cool. Yeah, that'd be kind of fun. You turn off gravity while we're on Earth. That's interesting. I wonder how heavy something has to be in order to kind of reverse the gravity a little bit. Like above someone's head. Like how heavy would that structure have to be to kind of make you get pulled up? Ideally to pull straight up so you're like, you just fall on that object. That might be too much. I don't know, but that would be really interesting. At least with space, it could probably be done. Wow. Think about a game like that in space where there's like really heavy objects that are kind of like football, but like you have to push off the heavy object and like dodge people, and there's like nets and hoops and like anchor things and this little freaking spaceship that's hovering around like the Earth, and you're just playing a game. That would be crazy. Oh my god. Footballing but in space. Holy crap. Anyway, but so how can we use this? So that's like one of the ways. So if nature has already done it, you can do it too in a way, in a more controlled and not direct, but what do you call it? Not imperfect. Intentional. There we go. In a more intentional way for a specific purpose that you want to get that thing done for whatever reason, right? In anything, like even like from the spiritual experience to very physical, structural things like an apple falling down from a tree. These things can all be figured out and used for technological purposes, because that's kind of the point of technology, is to replicate things so you don't have to do, all the hard work essentially. So it's basically get your cake and eat it too. When done well, you can eat your cake and have it too. What? Yeah. I said that correctly. I got confused about the saying. But yeah, so that's that. And the example that I have is kind of like, and sometimes it could be like and this is kind of like a nuance point where it's like if it exists, it can be figured out. Um, it might be wrong, and this is also another thing, especially when you're talking about really abstract things. It might be wrong, but it still acts as like a placeholder. So, like, I'm writing a paper right now. I'm sending it to the Nirvana Consciousness Technologies people about consciousness. It's called Belief as an Observer Effect. Consciousness. Well, title will probably be like Belief is doing an observer effect on reality. The implications of consciousness intent on structures. And in this, well, on random event generators. And then so it just kind of dives into, the implications of what that means. We won't, I'd like to get into it, but I also want to keep this short. So it will be for another time. Basically, it's like, well, it looks like we're getting into it right now. Basically, it's like one of the things that people didn't think about with the random event generators is that the people who are doing that change don't understand how the machine operates. Like, they don't have to understand how that machine operates, which that fundamentally means that there's a mechanism from the intention to the physical object of the thing, that there's some kind of automatic translation that is making whatever needs to have happen. And that could be for a multitude of ways that it could do that. And I'm wondering does it just use the least amount of energy thing in order to get that done? Because one of the things that one experiment had issue with was the canceling out noise, that everything was acting as noise. Like, there could be a bump on the truck that would trigger the machine, and like they would, get rid of that, and then something else would happen where it's like the condensation of the cup. Not really the condensation, but like maybe a train passes and then that vibrates the ground, which triggers the thing. And then so my thing is like, what if all of those things are actually what is triggering this machine based on the intent, because it's just using the lowest level energy thing that it can at that time. And there's experiments to actually test that. And then so that's what it like is listed on there, where it's like the implications of the automatic translation effect, because we already know that exists, right? Because that's what's literally being observed. So it's like, if you're looking at the simulation, like, what are you noticing? And so it's just kind of going into how can experiments be used to make more falsifiable tests about consciousness that are like pretty easy to do and non-invasive, and they're pretty easy to set up. Like, the machines are pretty cheap. You just have to sequence them and hook them up to machines and whatnot. Very easy to do. So that's that. And it's kind of, yeah. It was funny because I sent it to one area and they're like, oh, this is actually too short of a paper. And I'm like, oh, well, it could help all the papers that were submitted to this publication. Because you want people to test their ideas. Like, this is a way to test some of the ideas that, but I mean, well, to be fair, well, we'll just cut this out because I actually didn't really read any of the stuff that they had. So it might have worked out. We don't know. Maybe it didn't. Maybe it didn't. I don't know. But anyway, so, and one of the things that I came to was, in order to make the electron in this specific quantum random event generator, which uses quantum tunneling of the electron, it jumps about a 1 nanometer gap. So when it jumps that gap, it reads a 1. When it doesn't jump that gap, it reads a 0. And then the distance is 1 nanometers, because that would result in a 50-50 probability of the quantum the quantum tunneling going either 1 to a 0. So one of the things that needs to happen, because I asked AI, like, what's the energy that needs to be done in order to have that electron jump 1 nanometer gap, and it said about 1 to 3 electron volts. Now, did I check it? No. Do I have to check it? I probably should. I'm not, because it's just difficult and I don't really know the math. Like that, it just looks insane. Like I saw like a trident and stuff. I'm like, what the heck is this? But I love math, but like that's crazy. But it's just, like, again, it's just like I just don't really know it yet, and like all this other stuff. Like if it push comes to shove, then obviously, yeah, I definitely learn when I'm going to do it more closely. But as of right now, it's just like it's really more or less like a placeholder, because it doesn't have to be right, and that's the main thing. We know it's when you're making an intention, we know it's increasing the jump. It either increases it by 1 to 3 electron volts, either positive or negative, preventing something that would have jumped to not jump, or pushing something that wasn't going to jump, or something that was going to jump and maybe pushing it a little bit more to ensure that it gaps, or it just doing nothing, which is also a possibility that I haven't even considered until now. That maybe it knows it's going to jump anyway, so the intention doesn't do anything, and then all this different things. But we know it's affecting it because it is like there's more ones than zeros, so it is affecting it somehow. And the only way for it to become a one is to either add or subtract. Well, is either to add a 1 to 3 electron volts at some point, because it's consistently ones at one experiment that Jesse Michaels did, where it's like it was mostly ones and then he changed it to zeros and it went way down and stayed down, or stayed up, depending on what he was doing at the time. Is it important that it's absolutely correct? Eventually, yes, but for right now, no. Because we know it's doing something, and to throw out the baby with the bathwater is just stupid, right? So that's kind of like how you can use the simulation thing, where it's like, oh, are we living a simulation? It's like, yes, but you can use that in like a really cool way, where it's like, if it exists, it can be figured out. And then so the one thing that exists is, okay, well, it's jumping this gap by 1 nanometers, or not jumping, which means it's either increasing or decreasing at most plus or minus 3 electron volts. At the very least, 1 electron volt. So that means, at the very least, intention is increasing or decreasing electron potential by 1 to 3 volts that we know of. Like, for sure that's happening. Is it important that it's exactly 1 to 3 because it wasn't checked? Eventually, as the dates get closer, then yes, for sure, we need to know specifically. But again, when I talked about the other things where it's like, it's possible that, 1 second. Oh, well, I kind of made an interesting note where it's like, how could we test that consciousness intention is doing nothing at the times where there was going to be a positive 50-50 in the direction of the intention? And what's interesting about that, because I was just writing notes to gather my thoughts, is that technically that could prove some time travel is happening in a dimension that's beyond the 5 senses, which is really interesting. Where it's like, if you could show that the consciousness intention is not doing anything when it doesn't have to do anything, which is probably the more creative experiment out of all of these, and maybe not, I don't know, we'll see. That it would technically, like, kind of very obviously show that the consciousness intention is present in a way that would allow it to see into the future. Okay, so that would definitely make it so it's not entirely present, or it's doing something. Well, I guess, how would that work out? But yeah, so that's going to be in one of the experiments and stuff. But yeah, that's pretty much all I had to say. Kind of forgot what I was actually talking about. But hopefully this made sense. If you have any questions, put them in the comments, please. And if you want to check out how to create anything, how to do the things that are so cool, please check out the school. It's going to be free until I can guarantee that you're going to make money. And there's some things that I think I could do that could increase that potential chance. But yeah, so there you go. Enjoy. Oh, and the school thing is, I want to empower you to create fantastic and epic things that can help the world in some capacity, in some corner. That's what the Epic Projects Skool is about. But back to the simulation thing. It's not that, like, the word, the simulation, is just like, it's like spitting on the face of creation, of like how complex our most advanced simulation is. That's why I gave the example of that one technology, the 127 steps. It's like, that's probably the most advanced thing that we have, um, which I'm going to include the link down below. But, but, and this is kind of like the kicker. Like our video, like the thing that we created, you played video games that experience lag. Like, I want you to understand how stupid you are. And this is important because it can get better, and I want it to become better. But the video games that we've played has lag. That doesn't even make any sense. When was the last time you've lagged in real life? When was that? Literally, it never happened to me. Has it happened to you? I don't think so. Maybe if someone took like some psychedelic or something, maybe. But in real life, normal how it's going, fuck no. You crazy? You've never experienced lag in real life, okay? But in a video game, it happens all the time. And in a video game, it has like how many? What is there, like a couple billion pixels or something? Maybe a trillion pixels that you're seeing in a video game that's being processed every second, right? Trillion, maybe. So if we go to, actually, let me just double check that. So I know I asked this question incorrectly, and I don't know what computer it's using, but I said give me a high-end computer that's running Battlefield 6, and these are the numbers that it gave me. It literally doesn't matter because real life is just going to be so much bigger, it literally doesn't even matter. So just to read out some of these numbers. Okay, so here it is. So it's like GPU, in order to a GPU like AMD, so either a 590, RTX 590 or AMD RX 8900 XT to process the visual data. It's saying 1 terabyte a second. I have no idea if that's true or not. For a 4K frame that contains 8 million pixels at 120 FPS, that's about 4 to 6 gigabytes of raw frame data per second before shading and textures. Shading and textures, multiply that by dozens of GPU passes, giving hundreds of gigabytes per second of effective memory movement. So 0.5 to 1.5 gigabytes of data while playing a top end game. And you can have 128 players. So like multiply that 1 terabyte by like 128 terabytes per second for just GPU. And then when you do the CPU, it's like 100, it's like 80 to 120 gigabytes per second. Internet is an additional 100 to 300 megabytes per hour. Because it's 30 to 80 kilobytes per second. Disk and RAM is about 80 to 120 gigabytes per second. And then so when you add it all up, the total internet internal data movement is 1.5 terabytes per second or more. And the external, so the network stuff, they just said negligible by comparison. They said internet data, if it was a garden hose, your GPU is under Niagara Falls. That's funny. Holy crap. Like the information flow. That's such a brilliant way to estimate things. Oh my God. We need to do crap by like water, maybe. I don't know. Because like if you think about it, like that's a better comparison where it's like, okay, well, this is about like a garden hose and your GPU is making processes that are literally like Niagara Falls. So, figure that out. Like the internet ain't doing much. Like it's like it's like an insane tether that is moving and is just getting wrapped up in this insane amount of Niagara Falls water. But literally, if it wasn't that little garden hose wasn't there, the Niagara Falls would almost be pointless. I mean, we'd, play basic games, but no multiplayer crap, which is all the fun, really. But let's see, real-time ray tracing can involve billions of light surfaces. Okay, so a crap ton of data. That's what it's coming at. But, like, if you shake the internet a little bit, it's going to throw off that whole thing, or if the computer gets too hot, it's going to mess that up. But, in real life, the sun doesn't get too hot. It just burns. It might be too hot for us, It's definitely too hot for Mars. But it itself is fine. Like, it's like, no, this is just what I do, I get hot. And when it's the end, I just blow up and, everything becomes red, and then maybe a black hole if the sun is big enough. So, what am I saying? My God, I lost my train of thought. I have to scroll up a little bit. Oh, okay, so how much data does the highest... Oh, nope. That's a computer I literally just asked. Okay, and then so for real life, it's like... Okay, so those are like the processes for a second. It's like 100... Let's just go max. So 200 gigabytes... 200 terabytes per second, let's say, that the computer is processing every single second. Okay? So, actually, let's see how many pixels is 200 terabytes per second processing. Because, like, this is going to kind of put into perspective what I'm talking about. Oh, well, actually, that's a lot. So it says that it's 1.6 times 10 to the 15 bits per second. Which, hold up, I need to ask AI to give me the whole number real quick. 1 second. Okay, this is perfect. Because I would ask, like, AI, like, big numbers and stuff. And, like, I was always doing the calculations on my own. But then I realized... the ChatGPT can just do it themselves, and then they can just let me know. They can do all three things I like. They can give me the shorthand, they can give me the longhand, and they can give me the shorthand version of the thing in words, which is perfect. So this is what it said. 1.6 times 10 to the 15. Wow, that's a lot of zeros. How many zeros is that? Oh, 15 or 16. Oh, that's 1.6 quadrillion pixels it is calculating per second. Now, we can think of them like host, because, like, it has to process that. Like, every single pixel has to be processed and everything. So if we go... oh, my God. If we go to real life, what's real life simulating? This is going to put it into more perspective. The sun emits an astonishing number of photons per second. So how many photons does the sun emit per second? Because you could think of the sunlight as a host that is collapsing the wave functions, that is creating varying degrees of probability, or it is increasing or decreasing the likelihood of something continuing its normal state. So it's either like damaging something like DNA or something structural, or it's giving something energy. Okay, actually, we're not even going to go that far. We're just going to say how many rays of sunlight does the sun emit is going to be the number, technically, of pixels that just the sun. So we're not even talking about the rocks or the ocean or bioluminescent animals that are like in the ocean that are just doing its own thing, that are emitting their own light, that is going to be interacting with things very differently. Because again, when you see something beautiful, that is a calculation that is being interpreted and like it's being calculated and simulated within that. So it's like that whole, like, if you see something beautiful is probably more calculation than anything that you have seen in your computer. Like, just to get that animal to that place at that time for this specific purpose is an unbelievable amount of calculations and bits or pixels or whatever the crap you want to call it to simulate that. Okay, so the sun is emitting. So we can think of the photons like pixels that are interacting with things and changing them in a different way, because it's different now. Roughly 10 to the 45 photons per second. So just to give you that perspective, that's so 10 to the 45 with 45 zeros, or 46 zeros. It says 45, so I get, oh, okay, yeah, 45 zeros is quattro or decillion. Basically, this is like this is literally like cookie clicker end game numbers. Like, this is what we're talking about, like things that don't even make any sense per second. So in an hour, it's doing freaking like 10 times that, well, 60 times that. And then in a day, it's doing unbelievable numbers. Like, think of how many photons that have been existed, that every single one of them was accounted for, and not one of them made a dent in the lag at all. It didn't do anything. So that's what I'm saying. The sophistication that it takes to run that kind of simulation versus the crap that you're finding in your phone and your little computers and all this other thing, which is, I mean, by the way, I want to, very impressive. But to compare them, it's like, you know, just take a step back a little bit. You're not there yet, let's say. Which is the most important part, the yet part, because you can be very easily like, let's not be silly about it. But that level of gap of like 10 to the 15 zeros to 10 to the 45 zeros. Actually, let's see how many. I'm going to ask AI. How many times more is 10 to the 45 to 10 to the 15 ? And we can call this, we could actually make this into a number. We'll call this the solar computer. The solar computer number. We can think of a better word. Yeah, this word gives us an estimate for how close we are of calculating universal scales. The shorthand, good Lord. So let's compare 45. It says 10 to the 30, 1 nonillion, or 1,000 quintillion. So 10 to the 45 is 1 to the 30 times larger than 10 to the 15, which means 1 nonillion times more. God, the number of zeros on this doesn't even make any sense. Look, the sets of threes are, look at that. That's one set. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, well, I guess it's not nillion, so yeah, it would be 10. 10 sets of zeros. 10 sets of 3 zeros. That's the difference. So the order of magnitude versus the most advanced, probably commercially available computer that we have per second versus what the sun is just doing. So we're not talking about the animals and like, because everything is interacting and doing some kind of interaction. We're just talking about just the photons that the sun is emitting that is changing and just going out to doing something. Interacting with the plants here. Now, we're not talking about what happens, when that one photon enters into, a leaf that knocks the what is it called? The carbon atom off the carbon dioxide that it intakes in the freaking plant to release 2 oxygen that it just poops out, and then it keeps the carbon from the air. The plant is literally just growing its body from the air juice. from gas. That's so crazy. Oh my god. So we're not even calculating that number, that complexity. Okay, that's at least 3 steps. 1, it gets emitted from the sun. 2, the plant has to have the carbon dioxide in the leaf in the right way for the photon to knock it out. That's at least another step. Okay, we're counting that as number. So that's step 2. The plant has to do step 2. So after the photon leaves, the photon goes into the plant. It knocks off that little carbon atom. The plant keeps the carbon. It poops out. Okay, boom. Step 1, the photon gets emitted from the sun. We're not even going to talk about the plant. It's too complicated. Step two, because I'm losing myself. Step two, this is why I write everything down. Step two, it's important you do that. Step two, it knocks out the carbon and the oxygen. Okay. Step three, the carbon stays, the oxygen leaves. Step four, I actually don't know what step four is for the photon. Maybe it just gets absorbed and, oh my God. Yeah, it gets absorbed. My God. Well, I wonder how much of it gets absorbed. I saw like numbers where it's like 99% efficiency or something like that. Like, or like something like 80% efficiency for solar stuff or something like that, or some amount of efficiency. But I think it does release a little bit of heat, so some of that photon energy gets, pooped into heat or something. Yeah, so that's like, at least that's, you know, at least three steps. Let's just say three. There obviously is more thing that happens, but three steps, because it has to survive the atmosphere and all this other stuff. That's a number that gets simulated. And then it gets bent a little bit because of the gravity, and then nobody really thinks. And so it's like, that's one photon's life. He's doing all this. It's bending. Okay, so it gets emitted from the sun. Once it leaves the sun's, it's basically, it has to fight a little at least against the sun's gravity. So that's another thing that it has to calculate, that it has to simulate. So that's step two. Step three is it has to enter into the Earth's atmosphere and not get destroyed or bump into something dumb or something that's going to knock it off its course. That's step two. Crap, where are we at? Step three. And then step four, it hits the plant, oxygen and carbon. And then step five, it translates into infrared or gets absorbed. Well, it gets absorbed into the plant, maybe changes a little bit into infrared or something, but most of it gets absorbed into the plant. And then step 6, when the plant catches on fire, that light or energy gets released back. And then so now that the Earth just has, oh my God, the Earth is eating the sunlight. The Earth is gaining weight from plants, because when the plants burn, the gas just stays here. I don't think it leaves. So the Earth is slowly gaining its weight, very slowly. And the yogis who are doing the ojas meditation is slowly losing the weight of the Earth. So it's kind of like a nice little give or take, keeping her fit if she wants to. But yes, because, it makes things fantastic. But anyway, that's crazy. Bro, this is wild. Okay, so that's an insane thing. Okay, that's just one little photon, right? That's making the world a little bit heavier. Like, I don't even... Like, and then so it's like 1 on a million times more complicated. Like, 1 on a million times more steps, more pixels that are being calculated just from the one sun. Like, if we calculating everything out, that number is just gonna look ridiculous, because we have to account for all the suns in the world or something, or all the suns in the reality. So that's like at least another trillion, maybe, I think, or a quadrillion in the universe. I'm not even sure. So times the 10 to the 45 times 10 to the, a quadrillion. And then that gets you at least how much the sun is doing. Just everything that it, emits light in space, that's big. Then you account for the black holes. Like, the number is just crazy. Like, if you're trying to say that, like, the little computer, like, calling the computer a simulation and the world a simulation, it's like, it's almost offensive. That's what I'm trying to get at. It's like the magnanimous complexity and the orders of magnitude of complexity within real life versus the computer is like unparalleled. To just say, oh, well, the Earth's a simulation, and then it's like, yes, but you have to think of a different word if you want to say it. Simulacrum. That's probably a little bit more better, but it doesn't, like, something that captures just the complexity of what you're talking about. Just to say that they're equal, it's like, yeah, especially when you're like making stuff, that's helpful to think like that, because you're thinking of, okay, if it exists, how can it be used and all this other stuff? Or how can you make it to make something more beautiful or all this other things? Versus just like, oh, well, this is a simulation, that's a simulation. But yeah, I mean, that's crazy. I didn't know this. This is just insane. But that's like a little bit more perspective of why I'm like, like I don't really like using that, but it is generally accurate. At least when you understand the perspective a little bit more. But yeah, those are my 2 cents. 40 minutes long. Hopefully you enjoyed. This might be a part 2, just so part 1. Part 2 is the comments. Part 1 is the meat and potatoes. But maybe you need the comments, I don't know. Hopefully this helps. AI is cool. Oh, and to answer the question where people are like, oh, we're in a simulation, are we in base reality, and all this other stuff. People think that these things can't be answered. I just want to let you know, I think every question that you can ask has been answered to some extent. And the answer is no. We are not. Technically, if you listen to a bunch of like spiritual people and like all this other thing, the spirit has not left the spirit world, and it is currently dreaming of this one. So this is technically kind of more or less like a dream that you're having somewhere else. So no, this isn't base reality. In fact, base reality is probably just all of what God has to offer. So that's probably what people in the Indian and Hindu and yogic text call moksha, which is like merging one with the ultimate. Because that's all there is. If everything is made out of God's body and his mind, like all the physical stuff is God, all the energetic stuff is various aspects of this God, one particle or whatever you want to think of it. Think of this being as, then that would be the base reality, essentially. Everything else is just kind of hallucinatory aspects of that. So that's what that is. Now, that might be a lot for you. If it is, do the cupcake method. Have a little cupcake. Think about the cupcake. Enjoy the cupcake. Because the cupcake will literally distract you from all this existential stuff that may or may not come up. If you're having an existential crisis, fear not. Just go with the cupcake method. Or, hopefully, this message never comes and sees you. Those people. Another thing is to don't come to conclusions. That helps a lot. To just, this is just information. If it helps, it helps. If it doesn't, that's okay too. But yeah, so there you go. That's the answer. So because it is simulation, it's like, it doesn't really matter. Let's just make fun stuff now. Like, do you have your answer? Okay, cool. Let's make fun stuff.